So in this video, we're going to go ahead and graph one cycle of y equal to 4 times cosine of pi over 6x minus 7 pi over 6 plus 9. To do this, first we notice that our function is of the form y equal to a cosine bx plus or minus c plus d, where we see that a is equal to 4, b is equal to pi over 6, and c is equal to 7 pi over 6, and d is equal to 9. So this information can be used to find the amplitude, which is the absolute value of a. So absolute value of 4, which gives us 4. It also tells us that the period of this cosine function, which is equal to 2 pi over the b term, is going to be 2 pi over 6, which gives us 2 pi times 6 over pi. So with pi's cancel, leaving us with 2 times 6, and we get 12. And then we can identify the vertical shift, which is our d value, and so in this case it's just 9. And also we could get the phase shift, which we use as like our starting point when we find the x value of the 5 special points. So the vertical shift, phase shift, is equal to c over b. So 7 pi over 6, all divided by pi over 6. So 7 pi over 6 times 6 over pi. So the 6's cancel along with the pi's, leaving us with 7. All right, step 2 is we find the 5 special points, or 5 special points, or the x values of those special points, because we still need to find the y values. Okay, so the first one is going to be just taking our phase shift as the starting point. Since we're only going to graph one cycle of this curve, then it's good to start at the phase shift. All right, so the next two, to find the next 4 points, we want to find or divide the period into fourths. So take the period and divide by fourths. So then we know the period was 12, and then divide by 4 gives us 3. Okay, so this is how we're going to increment to find the remaining 5 special points. So for instance, x2 is x1 plus the increment of 3. So we get 10. x3 is equal to 7 plus, 10 plus 3, which is 13. And then x4, which will take the 13, and then we add 3 as well to get 16. And then x5 is the 16 plus 3, which gives us 19. Okay, so those would be the x values for the special points. Now we just need to find the y values of the 5 special points. Okay, and so we'll just create a table of values. So x, we know we'll have 7 will be the first one. And then of course, what is the y value for that? Well, we just throw it into our function, which is 4 cosine pi over 6 x minus 7 pi over 6 plus 9. Okay, so then first one, we would get 4 times cosine of pi over 6 times 7 minus 7 pi over 6. And so that's 7 pi over 6 minus 7 pi over 6. And so we get 4 times cosine of 0 plus 9. So we get 4 times 1 plus 9 to get 13. Okay, so let's go ahead and plug our next x value of 10. So then we have 4 cosine of pi over 6 times 10 minus 7 pi over 6 plus 9. So we get 4 cosine of 10 pi over 6 minus 7 pi over 6, which is 3 pi over 6 plus 9. So pi over 6 is the same thing as pi over 2. So we have basically 4 cosine of pi over 2. So that's 4 times 0, because cosine of pi over 2 is 0, plus 9. So we get 4 times 0 plus 9, which gives us 9. Okay, so now let's plug in our next value of 13. So we have 4 cosine of pi over 6 times 13 minus 7 pi over 6 plus 9. And so what are we going to get there? Well, let's see, 4 cosine of, 13 pi over 6 minus 7 pi over 6 would give us 6 pi over 6 plus 9. So 6 pi over 6 is just pi. And so that's just cosine of pi, which is -1. So we have 4 times -1 plus 9. So that gives us 5. Okay, so now we can throw on our next value of 16. So we have 4 times cosine of pi over 6. Pi over 6 times 16 minus 7 pi over 6 plus 9. Okay, so that's 16 pi over 6 minus 7 pi over 6. So that's going to give us 4 cosine of, let's see, so 16 pi over 6 minus 7 pi over 6 would give us 9 pi over 6, and then plus 9. So that's cosine of 3 pi over 2, right? 3 pi over 2, and we know that cosine is 0 at 3 pi over 2, so we have 4 times 0 plus 9, so we get 9. Okay, now let's go ahead and throw in 19. So we have 4 cosine of pi over 6 times 19 minus 7 pi over 6 plus 9. And so that's going to give us 19 pi over 6 minus 7 pi over 6, which gives us 4 cosine of 12 pi over 6. Which is just 2 pi. So then we have 4 times cosine of 2 pi, but cosine of 2 pi is a positive 1, and then plus 9 gives us 13. Okay, so now that we have all our special y values, the special points, or the 5 key points, are the values, or the pairs 7, 13, 10, 9, 13, 5, 16, 9, and 19, 13. All right, so step 4 here is to plot the points and connect the dots. With a smooth curve. Okay, since we're going to do one cycle, we'll go ahead and see how much scale do I need here. We'll go ahead and start it at say 5, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20, 21, 22. Okay, so I'm not drawing it to scale in terms of the x-axis. In terms of that, we'll put it's not centered at 0, in other words. our y-axis here. It's not drawn to scale there. Okay. So it's not positioned there. According to this, it would be positioned at 4. But let's see, let's go up. Say, I need to drag this down just a tad here so I can get more space. Okay. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we need to go. Okay. So plotting this here, right? We have our y, our x, and our y here. And let's go ahead and plot our points. Once again, I'm not putting the y-axis at the origin. I started it at 5 there, so it's not drawn through the origin there. So the squiggly line there just indicates that. All right, so let's go ahead and plot our points. And so our first point is at 7, 13. And then our next point would be at 10, 9. And then our next point would be at 16, 4, 16, 9. Excuse me, 13, 5, my bad, 13, 5. And then at 16, 9. And then 19, 13. So those are our nice points there. And then we would connect it with a nice smooth curve that resembles the cosine graph. All right, so that's one cycle of that curve. And of course, if we wanted to plot more of these, it basically would carry on in both directions that way. But of course, we only wanted one cycle of this, so there we go. Okay, so that's the graph of our function. That's it for this video.